Good morning, friends. Welcome to Engineer Law Civil. Today's seminar topic is underground construction or tunnel engineering or tunnels, about tunnels, and about underground construction techniques. Details about those we'll study today. As before I had said, you can use this topic anywhere in any engineering year, first, second, third, fourth year, in any mini project, anything. You can use this topic. If you like it, please subscribe my channel and continue watching the video. You'll learn many things today. First of all, we are going to see some of the basic questions that are what goes underground, why it goes underground, how it is underground built, where are problems encountered while building it underground, and when do it risk getting mitigated. So first of all, we'll see what goes underground. What are the things those goes underground, right? V- uh, what goes underground? You can transport, you can stay. First of all, the shelters in the design homes, fully designed homes, are underground built. Basic protection from enemies and elements are built underground. Partially modified for added protection and comfort are built underground. Drawings, built drawings and specifications of houses, fully designed homes are built underground. Mining operations are done underground. Open pits transitioning to underground mines, exploiting loads to tap and reducing environmental footprints are done underground. You can see in the figure. In this figure, you can see that quartz, the small tunnels are done underground. The collection, supply, irrigation, and distribution of waters are done underground. Water lines, water track, water pipelines are done underground. Canals, way to canals are done underground. Sewage treatment plant in Bondi has been constructed underground. Right? Here you can see the mass transit system. The transit system in many countries are done underground. From underwater, you can see in the third figure, from roadways a tunnel has been built. The vehicle goes directly underwater and reaches to the second part, or you can go underground under the mountain in second figure. Underground, the main hall auditorium has been built up. While after making underground things, the road traffic has been reduced to its much level. You can see the image of 18th 19th century and 21st century. You can see the difference of the traffic, right? You can also, like, the other examples are high pressure tunnels are done underground, powerhouse has done underground, surge shaft are done underground, hydroelectric power plants are built underground, right? The fuel storages has been in underground. Other ground storage media like solution mined salt domes are underground. Depleted reservoir rocks and lined hard rock corners for generation of carbon dioxide, compressed and liquefied natural gas and LNG are done underground only. The package and bulk materials are transported underground. CO bunker storage are underground. Coal, grains, ore, warehouse are converted into mine space has been stored underground. Right? The critical infrastructures like controlled exit entry, other secure sites with network, and the environmental control like temperature, humidity, ready for modification, space, costing, heating, cooling, communication, data transfer, wastewater, fresh water, transport, power, electricity are there are many things that are constructed underground. Here are some example what are the infrastructure that are constructed underground. These are the examples of the infrastructure that those are constructed underground. There are many more examples. Some of the examples are some research facilities constructed underground. The worldwide many underground research laboratories and test cities like waste repository and characterization, physics, bioscience, engineering, research, education and training are constructed underground. Some of the public facilities are also constructed underground. Some of the malls, parkings, and many more auditoriums are constructed underground. Pretty much anything you want can be constructed underground. You can see over here, right? Then the other question we have in mind, that why do we go underground? What are the reason behind? First of all, traffic, urban congestion. Go underground to avoid road pavement, buried infrastructure, basement and foundations, surface contamination, right of way interruptions, minimization of surface disruption. Now, the second main reason is to create green space. The Central Artery Tunnel project will create more than 300 acres of landscaped and restored open space, including over 45 parks and major public plazas. The third main reason to go underground is for protection. Protection, no damage to the underground shopping mall located below in earthquake prone regions. No damage to the severe in Kobe City Hall when earthquake happens in Japan in 1995. The second most important thing is isolation. It is quiet, it is shielded, it is stable, it is waste isolated after many experiments and testing. Then how is underground built? You have studied what goes underground. Then you study why we goes underground. Now we are going to study in civil engineering main part that how we could build this underground. There are many methods to build underground construction. Some of them are specifically cut and cover method in open excavation, cut and cover method between earth retaining walls with lower of groundwater levels, cut and cover method between earth retaining wall without lowering of groundwater levels, wall and roof method, pneumatic caching method, immersed tunnel method, bored tunnel method, top down method. Okay, now first the cut cover construction illustration. You can see 6 major diagrams. In the first diagram, you may see that the construction of diaphragm wall, decking, and pin piles of at left area. Right, the space has been digged. In the second most diagram, you can see the construction of diaphragm wall, decking, and pin piles in the right area. First of all, it was built only in left area. Then it is built in the right area. Then after that, the strut are installed at the centermost area in the third figure. In the fourth figure, you can see the up-down main structure, right? In the fifth figure, you can see the pavement restoration in section. And finally, in sixth figure, you can see the completion of underground section. In this, first of all, it is digged. The left pile is digged, then the right pile is digged, then the struts are installed, then the excavation is done, then the main construction has been down to up has been started, then it has been restored, and then the soil are filled, and the completion of underground action has been taken. Now you can see in the 3D view from top to down construction method. First of all, we had gone to down to top. In this, you can see that in cut and cover we had done from down to top. Now we are going to see from top to down. First of all, we'll install the retaining wall, right? Then the excavation and installation of steel strut are done. To hold the soil, we have to install the steel struts. Then construction of underground structure has been started. The construction of underground structure has in the middle part, and in fifth diagram the construction of underground structure has been completed, and finally the backfilling of soil has been done. You can see here in more detail parts the installation of retaining wall that or a diaphragm wall. The second method, construction of guide wall has been done. Excavation of panel, installation of rubber cage, and then repetition of the concrete of panel, and finally repetition of this process has been done. The process has been repeatedly done. In the main figure you can see the number 1 point, guide wall has been added. Number 2 point, excavation panel has been started. Number 3 point, gates has been installed. Number 4 point, concrete is done, concreting is done. And number 5th point, it is in 5th, it's not a point, it's saying that the process will be done repeatedly. In this figure you can see the underwater construction techniques. Now we'll see the excavation by tunnel boring machine. This is the next method, right? It is shield tunnel boring machine involved the following activities. It's a tunnel boring machine. We bore into the tunnel, we bore into the mountains, we just goes ahead. Excavation and support of working slabs. It's a tunnel boring machine, and we're going to learn about some of the activities of this shielded tunnel boring machine. The excavation and support of working shafts, excavation and support of undercut and tail tunnel, excavation of tunnel itself, disposal of soil from tunnel face, pushing the soil to ground level, lining the tunnel, extending services and rail tracks, excavation and support of removal shaft. Here you can see there are two machines in excavation and dry soils. First is earth balance machine and second is digger shield. Now you can see the excavation in wet soils. In slurry shield, excavation is done from this machine. Now in excavation of rocks, there is same machine but with different blades. In rocks, hard rocks, mechanical equipment or explosions are used. Blasting are used in hard rocks. The person in charge of blasting shall be last to leave the blast area, shall see no one remains in the blast area, and shall operate the seasoning switches in floating line while proceeding out of the blast area. And these are the instructions. After each blast the underground supports in the blast area shall be inspected and secured. Necessary work, the rock bolts within 100 feet of blast shall be tested after each blast. The much piles shall be wet down prior to kept wet during operations. Some ground improvement options: freezing to stabilize the ground, and preserve the groundwater grouting to stabilize the ground or render it watertight. Here you can see the pre-drilled compaction grouted hole to desired depth, and insert compaction grout casting in pre-drilled hole. Begin pumping low slump compaction ground mix stages with withdrawal at controlled rate. without casting as stages are complete until the hole is completed. You can just drill the rod, compact grout casting, and then casting, and then pull the rod back and the soil will be filled up, right? Now, some of the ground support systems are like steel arches, rock bolts, steel channels, shotcreting, cast iron segments, precast concrete segments, and integrated waterproofing. Here you can see some of the diagrams from Burnell shield and type of ground supports you can give to the tunnel from inside. Here you can see the diagrams. Now we are going to learn the technique of jack box tunneling. It is the simplest form. Just keep in mind that a box has been prepared in the industry, and then it's transported to the field, and then with the help of containers and trucks, the box is just pushed into the soil, and just that's it, jack box tunneling. You can see the detailed diagram. The box is just pushed in that tunnel, and a tunnel in that soft soil, and the tunnel has been made. Now we are going to learn what are the problems encountered during construction of tunneling, right? First is ground surprises. Of course, we are constructing tunnel in underground, then the ground is the main trouble that we encounter. Geomaterial properties vary from time and space. Its geostatistics, strengths, load, stresses, deformations. Of course, it will vary from soil to soil. The design structure and surrounding structure environment are sometimes the engineering process fails to amount the impacts of geo-variabilities. These are the major excavations happen in India, in whole world, like in Munich, in Sangal, in London, in Singapore. The above ground just fall down because of excavation work, because of underground. So in worldwide major projects, major losses has been done. These are the list from 1999 to 2005, and let's see, we'll update. Fractured rods subjected to stress and gravity. It will the fractured rods which are subjected to stress and gravity failed due to spalling, bursting, revealing, alteration. Has failed as mild. Observe at the engineering scale, a rock is rarely solid. A hard rock mass may contain weak clays and even voids. Changing groundwater condition. High water pressure complicates arrowhead tunnels. Now our next question is, when do risk gets mitigated? When you can see in studying the regional geology, of course you are building underground, so you need to study the geology of that soil. Every soil has different stresses, different loads, different characteristics, different properties. You need to, if you want to build a structure underground, you need to study all those characteristics of that rocks, of that soil, whatever, to dig it, right? Now in scoping the site investigations, mixed scale data sets are used, experiences are needed, file investigations like exposure, geophysics, boreholes testing, field testing, lab testings are very important, and characterization of subsurface site. The 3D models are made from centimeters to kilometers. Basics of designs are made. Conditions like dry, damp, wet, massive, hard, straight, semi jointed, blocky, crushed soil like or calculated are taken, and the behaviors like running, flowing, squeezing, wearing, spelling, rock bursting are being observed, and deciding between options like setting design constructions had been made, and design specific for geodiversity, plan for variation, geologic designs and construction changes are made. In conclusion, we can say that in overall conclusion, first we had said that what goes underground, pretty much anything that could be placed on surface could go underground. Our next question was why we go underground. There are many advantages, there are many cost, risk are main drawbacks, but there are many advantages we go underground. How underground space created? We are civil engineers. Technology exists to build up pretty much, but uh, geomaterial we have to use that very carefully, right? That where problems are encountered underground, all problems like foolproof solutions. There are no foolproof solutions to any of the problems. Okay, there are some problems eventually. When do risk get mitigated? Opportunities for risk management are there, they need to be sized. Who can best mitigate the risk? uh, like researchers, collaborations together at sites. So here are the some references we had taken to build that PPT. You can go along that. Okay, thank you guys, thank you so much. If you like my channel, please like, share, subscribe, and please give your feedback on the comment section. Thank you so much. I'll come with the new seminar video much soon. Thank you.